All right.
Yes.
Ray Uberecken, AA0L, Ray's lifelong passions for astronomy and radio began in Cub Scouts. He became a licensed amateur radio operator in high school before entering the Navy in 1955 and has maintained his license ever since. Now licensed AAOL, he obtained the class as extra in 1978. He put ham radio and astronomy together as a hobby in the 1960s, doing moon bounce and measuring sun and galactic noise. He maintains radio and optical observatories at his home east of Colorado Springs, Colorado. Ray's employs a broadcast engineer babysitting 2 a.m. and 4 FM stations. Ray's a long time member of the Deep Space Exploration Society. Enjoys building receiving equipment and feed antennas for their 18-meter dish in southeast Colorado. Ray is also a member of the Colorado Springs Astronomical Society, Society of Amateur Radio Astronomers, American Radio Relay League, and life member of AMSAD. Current interest in is cosmology and proving the various theories of how the age of the universe is calculated. Ray's work on pulsars and resultant measurement and dispersion measure is an excellent input to his work. And I have to say that we have that tower that is behind me that we changed the feed on. Ray's 80 plus years old, and he's still gets up that tower faster than anybody I know. So he's still he's in outstanding shape, and I'm jealous as heck. Ray, go ahead, and I'll flip slides when you tell me.
Okay, very good. Thank you, Rich. I've been around the DSES group for a long time now, and got back interested in it. Originally started back in around 2000 or even before that, and then I kind of slacked off for a while and got back interested in it again about 2010, 2012, right in there, and I've been associated with it ever since. But one of the things that happened, I'm going to give you a little explanation of this particular site. It actually looks like something now, but it didn't always look that way. And I've been around a long time. I actually tried to buy it back in 1984, along with several other people here in Colorado Springs. But I'll go into that a little bit. But the history dates back of this site back to the 1950s, maybe even a little bit before. I'm not exactly sure. But the site was originally owned by the National Bureau of Standards, or the government. The National Bureau of Standards operated it. And it had a 500-foot tower on the site and several trailers and all kinds of things. And they actually measured temperature, pressure, and all that sort of stuff on this tall antenna or tower. And the actual antenna, the one that you see on the right of your screen, the dish, came along later. It actually came along in the middle 1950s. The site was actually there ahead of time. And then the site was stopped being used in about 1972 or so, somewhere in there. I know some of the guys that worked in this site, and they hated it. It sits out in the middle of absolutely nowhere. And they had to put in a couple of weeks there, and there were bunkers, and there is a large bunker, maybe 30 by 50-foot bunker that sits about 600 feet away from where the current dish is, but it sat right next to where the tower was originally. And they would go and operate from that bunker and live down there with the snakes and everything else that happened to be around. But that's all that's around. I mean, you couldn't raise one cow on this land. It's just nothing grows there practically. It's like the surface of the moon. So back in the early 50s, it was a pretty going place. And then they quit using it in 72. And later on, in about, then they have to wait about 10 years before they actually sell it once they quit using something. And so in 1984, it went up for sale. And I and several others, 5 others in Colorado Springs tried to buy it. And we knew that we didn't have any money, and so we really lowballed it and thought, well, if nobody wants it, and we couldn't figure out anybody in their right mind would want this place, that maybe we might come up and get it. We had ideas of operating it remotely from Colorado Springs via amateur radio. So we were not successful. Somebody did want it, and they bought it, a fellow by the name of Plishner. As you know, that we have called this site the Plishner, Paul Plishner Radio Telescope or astronomy site. So they got it, and they tried to sell it. They tried to lease it. They tried to rent it. They tried to everything they could think of for around 20 years, and never were successful at doing anything. Nobody was interested. It's not even, it would cost you more to scrap it than it's worth, I think. So they had this site, and it's actually 17 acres of site, and it sits out in the middle of what would normally be anywhere else farmland, and they do farm it. But I'll be honest with you, this year, and Rich can verify this, there is nothing growing there. And they didn't get any water this year until about, less than a month ago, I think, just a matter of a few weeks ago. They finally got some water on the land. But it sits down in southeastern Colorado near a town of Haswell. And Haswell is a town that used to be on the railroad. They have a grain elevator there. It used to have stores and things, but nowadays maybe only 1 out of 5 of the houses even has anybody in it, and it's just a broken down old, almost a ghost town. So and there's a few people living up there, but not very many. And so it's I don't know what else to say about it. It's barren. I mean, even snakes don't like it down there, I don't think, although we have found several different varieties, including rattlesnakes. So anyway, none of the equipment that's on the property now was there back in 1984 when we tried to buy this property. And the pedestal was there with the dish. And the feed tower was not there. The trailer wasn't there. None of the little buildings that we stole from the railroad are there. There was nothing except an underground bunker, which is about 30 by 50 feet, roughly, and the pedestal and the antenna. Everything else had been pilfered from the site. There was no coaxes. There was no nothing. All the radio tower had been sold off, and everything else was gone. So, and it wasn't even a gate or anything like that getting into the property. The fence had been torn down. And so the farmers do farm that land around there occasionally, but not this year. There's no crops this year. So anyway, fast forward then to about the year 2008. And, let me step back a little bit. Back in 2001, something happened in the United States called the 9/11 episode. And then along came Homeland Security. Well, DSES took care of 2 dishes like this, exactly like it, sister dishes, up in a mesa north of Boulder, Colorado. There are 2 of them up there, and that was right close to where everybody lived. And so they had taken care of these dishes after they after National Bureau of Standards quit using them, and put new motors in them for the drive system. They put all kinds of readouts and things like that. And they actually used the dishes a little bit for some science experiments at 1420 and other frequencies. So that group, the Deep Space Exploration group from up there in Denver, Boulder, Golden, Fort Collins, up in that area, northern Colorado, took care of those dishes for about 20 years. Then along came 9/11 and Homeland Security, and all of a sudden people started getting a little bit nervous about people coming on to government property. We even had our own gate, basically, that we came in the back side of it, and they shut us down. So all of a sudden, Deep Space Exploration Society did not have anywhere to operate. And so this dish became available. Some of the guys were energetic enough to contact Mr. Plishner, talk to him a little bit, and he donated the dish to Deep Space Exploration Society. So after all those years, I actually got it for nothing. So, and you can have it too for nothing, $50 a year dues. So anyway, the people in Boulder then started, because they had to get off that site up there with the other two dishes, they started moving all of the equipment that they had been able to energize those dishes with down to the Pulsar site or down to Haswell. However, Boulder's a long ways away, and it was a long drive for them. So they would come down to this site and live in that bunker. And then when they finally got a trailer moved down here, they actually, one of the guys had a bunk in there, our little sleeping bag that he slept in. And so they came down about a week at a time, a few days at a time, and they would come down and work. And they did most of the work, early work. And so Rich and I and Bob, we're standing on the shoulders of these guys that came before us and did much of this work, getting the drives ready and actually moving the antenna. The antenna sat in a bird bath position for about 40 years before it actually moved in 2012. So the guys came down here and worked at it and got it going between 2008 and 2012. Now understand that there is nothing, there's no stores close to us. There are no stores in Haswell. About 30 miles away, you can get to some stores like a Walmart or a Home Depot or something like that, but you got to drive quite a way, and you have to drive that far for restaurants. You have to drive that far if you're going to stay in a motel. There are no stores really in, nothing that you recognize as a store up in Haswell. So it's a long drive and it's difficult. Well, the people in Boulder had to drive a couple 100 miles to get here. And so it was a long way, and they would come down for like I say, several days at a time. Well, they got tired of that after a while. And about that time, some of us from Colorado Springs got very interested in it. And we started coming down here. And so slowly but surely, we got a bunch of people, and I know that Wolfgang yesterday mentioned something about there's usually 10 or 20 people that do most of the work, and everybody else is members only. Well, that's the same down here, of course, and so we've always had only about maybe 10 people doing most of the work at any given time, but those 10 people stand on the shoulders of the ones that came before them. And so do we. And so a lot of people did a lot of work at this site, and still continue to this day. Some of them do software, and some of them do hardware. It's just a little bit of everything. Anyway, about 2012, it moved, and I was there the day it actually moved for the first time in 40 years. And so it was very exciting, and I just got all back into it from at that time and started coming back down. And so nowadays I work on feed antennas and some electronics. I build various things. So that's why we are very excited. And this has been a long, drawn out 12 years getting this site to where it gets its first Pulsar. And we are excited to be the ones that actually did that. And everything here that you see at that site, the drive motors have been replaced. They're all different. Initially, this place had 480 volts or something like that coming into it at like 900 amps. It was a huge amount of power coming into the site. But in the meantime, once the National Bureau of Standards quit using it, the power lines fell down. The place didn't have nobody was using any power, so they tore out all the power lines. So we've been working all this time, first of all with a 4,500 watt little portable generator. Then I got him a 25 kilowatt generator, and one of our members got that working for us and got it all up and running and wired the place. We buried cables from all of the buildings, from the tower to the trailer, and over to the bunker. And now we have, thanks to Skip Corelli, we have power at this site. And we actually have AC power. You can go in there and turn on a switch and something happens. And you don't have to go out there and kick the generator 14 times or so to get it to work. So anyway, nowadays, it's much much improved over what it was. There's all kinds of activities and things going on around it. We have various antennas for different things. We have a complete ham station. The bunker's all been restored, although it blows in with sagebrush so much that or tumbleweeds that we don't actually go down it very often anymore. I don't think Rich and I have been down there in a long time. I'm just reading here a couple of comments. Yes, AT&T and T-Mobile work off of Yellow Towers about 15 miles away. And yeah, we don't have internet at the site at this particular time, although we did for a little while. And so anyway, it's now getting into good shape where we can actually use it. And we, in driving down from Colorado Springs, I should talk about that because there's no place to really comfortably stay down here. Some of our guys do stay down and overnight and down in the bunker, but it's not a fun thing to do. And so we mostly drive it and come down here one day and go back home. That's about 5 hours driving time for the average person. It can vary anywhere from about 4 to 6 hours, but its average driving time is around 5 hours for us. And so out of your day, if you spend 8 hours down here, that's 13 hours. You've spent a long day and it's been a hard day. So to come down here and particularly at night where you're going back in the middle of the morning, it's pretty tough, particularly for us old guys. And so nowadays we're going to have internet here in a couple of weeks, and that's going to improve things considerably. So let's go on and talk a little bit more about the actual dish. As Rich changed it here and in our Pulsar work. So Rich shows you the feed on the right-hand side. I built that feed, and I built what we call the quick change harness below it. This top of this scaffolding that we go up to work on the feed antenna goes right over the top of scaffolding. And so, but it was very difficult to get around the front side of it and actually put new feed antennas on. It was downright dangerous. So we do have tie-offs on the feed itself when we go up there with our safety belts now. But so I built the feed mechanism, the quick change mechanism that you can see, and then the feed antennas that I build will all fit into that, and they'll all just slide in, and 4 little 1/4-inch bolts, tighten them down, and you're all set to go. And then there's a feed box up there that can house preamps and relays and all that. And when we do the moon bounce, we'll stick the moon bounce equipment up inside the cavity up there that you see behind the feed antenna. There's enough room in there to put some even rack-mounted stuff, if just 1 or 2. So anyway, the feed antenna, and the reason I chose it was because of we had a lot of data at 408 for pulsars, and we wanted to go after pulsars. So I just arbitrarily said, "Gee, let's go there." Pulsars seem to be really strong there, and that for us getting just this operation of this site going for the first time, very important. So we wanted as much advantage as we could get. So the dipole feed is an EIA dipole feed, EIA standard gain antenna. I saw it used up at the Boulder sites back in the 60s. So I thought, gee, why not use that? And we'll start out there. And so that's what we did. That's what you see. However, if you'll think about this dish is not painted white. And there's a problem with that. If it's painted white, it disperses energy, light, and also hopefully infrared, the heat stuff. But this dish is just plain aluminum. And so if you aim it at the sun, guess what happens? You melt the feed. And guess what happened to this feed? I just took it down on this week, Saturday, and brought it home, or Friday rather, excuse me, brought it home, and sure enough, the sun, when we were tracking, I think it was the crab pulsar, was too close to the sun, and we melted one of the little plastic pieces that holds the dipoles. And so got to replace that. But it didn't hurt the antenna. The antenna still operated normally. And we have a new box up there now that shows all these coaxes terminated a little bit better, so it looks much nicer. But I have a 1420 megahertz feed that also slides in to that quick change harness, and it has a latch, and so it folds down underneath what you see there, and it's right there where we can sit on that platform and actually work and change the feed antenna. So it's much safer, no hanging over things like we had to before, and it's much lighter as well. So let me go on here and talk about the rest of it. We have a very simple preamp up there at the antenna. It's about a half a dB noise figure, maybe around 40 degrees Kelvin, and it's runs about 30 dB, a little better than 30 dB worth of gain. And then that goes immediately from, it's right at the back of the feed antenna where there's a balun. It's located right there. And then from there, pipes it into another preamp inside this preamp box that we have up there. And from there, goes down through a half-inch heliax coax of about 200, 210 feet long into the trailer. We have two coaxes running up there, but they are not the same length. They go different routes. We put the other ones in a little bit later, and then this one. And so then there's the other preamp runs just about the same noise figure, and it runs about a little less gain. So we have a roughly about 50 dB gain overall up there at the dish before it comes down through the coax. So the noise figures is well determined right up at the feed point. And so you see that. Then we feed everything with 12 volts through the coax with the bias T. And Rich will tell you all about bias T's. He knows all about those. He burned up. He's burned up at one or two himself. So anyway, that's I guess that takes pretty much care of everything up at the tower, up at the feed antenna. Down in the trailer, we have the EDIS N210, and that is the SDR that was donated to us from one of our members, and he said he was not using it. In fact, we've had a second one donated that same way, and Rich can cover that a little bit here. But this is the hardware that we used for detecting the pulsars. That goes into a standard laptop computer, and then Rich loads up all the software, and away we go. Now, one of the other things that it's gone on. Wolfgang asked what is the F over D? The F over D ratio is 0.41 actually, and I have a 3.7 meter dish at my house that has a 0.4 F over D. So everything that I build to take down there, except the 408 antenna, I test at my own house. I've got a 1420 and a 1296 all set to go down to the dish, and they're done at my house. So now we go to this the EDIS, and that's really the power of the whole system. Although we've had a lot of trials and tribulations trying to learn how to actually operate it correctly. And then the software, the GNU software that we use, Rich has up there right now, shows you where we adjust the gains and set the bandwidth, and we're trying to do everything. But we're limited to about 20 megahertz or 25 megahertz with this, and most of these pulsars were all done at 10 megahertz bandwidth. We at first did not receive the signals at all, and we were really disappointed on our first trial down there. And then we said, you know, maybe we should back these gains all the way down. Maybe we're not operating even linearly. And so we did, and sure enough, the pulsars were there and came right out. And that pulsar, the 54 pulsar, we call it anyway, the declination of 54 plus 54, we can see that one because that's circumpolar. We can see that all the time, and we always go to that one first up there to make sure everything is working correctly. So let me go back here. Yeah, Rich is showing you some RFI. That's not necessarily all RFI, but unfortunately, they said the reason you choose 408 is because 406 to 410 is a protected band for RFI for radio astronomy. Well, not down there, it isn't. Uh, we have a cell tower, and sure enough, they got all kinds of crap coming off that cell tower right in the radio astronomy protected area. So we have to mitigate things. That's why we actually moved our 25 megahertz or 10 megahertz bandwidth up a little bit to about 420 and center frequency, and that's where we actually detected the pulsars at. Otherwise, we have to contend with all of the interference from that cell tower.
Got one question about why we don't put the SDR directly at the feed point.
There's no need to. It would be more difficult. The SDR, the noise figure of the system has already been determined. So it is more than ample signal for the SDR, and there would be no benefit to putting it up there. In fact, it would make it a lot harder on us because we're continuously moving things around and testing it, and that would make an awful long USB cable. We'd have to stretch that because it runs off of USB power, and so yes, we have to keep it down by close to the computer. Now, I should also tell you that we didn't for a long time have any heat or any air conditioning down there, and this is Colorado. It gets cold and it gets very hot. But nowadays we have 2 air conditioners running in there. We have full-time power, and we have everything. Oh, boy, I'm over time here, I guess. Maybe not quite. Okay. Okay. So we have this is one of the 2 or several of the guys developed the software. Everything is hand done. It's all done by us. It's not, we didn't purchase anything. These guys actually, other than the EDIS, and that was given to us, but these guys actually wrote all the software, and they have this is the computer that maintains us on target. And so we've been doing it manually by moving, if you can think of these little circles, concentric circles, those are like the bore sight or a scope sight on a rifle. And so we move that in relation to the target. So the target, if we move the circles down, they stay where they're actually put on the screen, but the target comes up into the center of it. And we try to keep it there. The center part, the yellow trace, is actually about 0.15 degrees radius. So it's about 0.3 degrees across. The other one's about 0.5 or so, 0.6. And then, so we can keep it easily within the 3 dB beam width of 3 degrees for this antenna, for this bead. And so it's done by a couple of manual switches, and we kept moving it. Boy, I've got some good news to tell everybody. A week ago, these guys that wrote all this software actually got it to run the dish automatically now. We have, instead of manual control, we now have automatic control, and it's a pleasure. We actually ran out of things to talk about. We didn't have to pay attention to those switches all the time, keeping it all centered while we were trying to make the runs. And the runs can be several hours long, as everybody knows. And so it was kind of we'd lose attention every once in a while to the project at hand. And so we eventually now have automatic control, and it's no problem for us anymore. Go on to the next slide, Rich, unless you want to say something about it.
Oh, good. Go ahead.
Okay. There's the other member of the group. That's Bob Haggart, and he's out there. He built a very nice bench while we were doing some of this, getting it all ready to go. And he was building a bench inside of the trailer. And so when Rich got done with his first Pulsar run, he took it over and set it on that brand spanking new bench and found the first Pulsar. So that's number 54. That all of a sudden, when Rich got the timing right on it, it just popped out, and it was there for sure. We had finally done it. Go ahead, the next slide. There's Rich and myself, and we're pointing toward our success. And I'll tell you, we were a lot happier than what what shows there. We were really, really excited, and as culmination of so many years and so many people doing work at this site to actually get it to this point. And you see behind my head is the manual control. It's got a couple of regular old toggle switches on it and a couple of knobs, and those are the speed knobs for azimuth elevation. And there it is. And we have a couple of switches to raise and lower and left and right, or clockwise and counterclockwise. I might point out that underneath the spectrum analyzer is where I've recently done all the coaxes, cleaned them up, and got them all wired in. And we have preamp power just below that. We have a spectrum analyzer that we do always check. And in between runs, we often check just to make sure that everything is still working. Over on the left, on the lower part, I might make a comment that is a signal generator, and there are a couple of computers below it and a screen behind it. And that stuff belongs to Skip Carilli and his experiment with the SETI project. So we have actually been working with Skip also. So anyway, that's mainly our control. Not anything like the Stockard-Pelier, Astropelier group, but or Astropelier-Stockard group, but it's certainly it's a lot of equipment for us. We didn't have anything before this. So back to our pulsars. You see the pulsars and the lines going up through, and the dispersion measurements and all of that. But when all was said and done, and Rich got the timing trimmed, everything fell into place, and it was a great day for us. Let's see, we have that in here, I think, don't we?
Yeah, we do. And I want to comment on this thing. This is what it looked like. I used Tempo, which is the timing software. This is the raw data, the first that came out. When we saw those lines came up, we just knew we had it, even though it wasn't tuned up yet. That's the first pulsar ever before any tuning happens. But you tell it's there, and you just haven't tuned it up yet. But that's the most exciting time we've had, is that picture there.
Yes, and the next slide shows you a better, that's after Rich cleaned it up some, and you'll see where the dispersion measurement came out right where it's supposed to, and everything really looks clean. And we go back to this same pulsar all the time because we stow the dish at 317 degrees and declination, or straight up at 90 degrees, straight up in the birdbath position. But the first thing we do is we tilt it down to the horizon, and over in that northern part to the north is where we always can find this 54 pulsar, so that we go over there and look at it and check out and make sure the system is working. It only takes just a few minutes. And then Rich also did some pulse width measurements on it, and this is the very bottom of the page. And
yeah, the Presto software produces a text file that allows you to pull that into Excel and it does one pulse period of data from your analysis. So you pull that out and you plot it, and this is what it looks like to plot. But one of the key things there is that you can actually zoom in and try to analyze the pulse width. And this is and the main number there is that the 50% of the height of the pulse is called W50. That's in the ATNF database, and that, you know, this thing at plus 54 is 6.6 milliseconds, and just from the numbers here, I was able to get 6 milliseconds measurement, which helps you confirm that you actually got the pulse, or you actually got the right pulsar. So we do this on all the pulsars that we get, just to verify that it works. And it was interesting. The one we just got was the 1133 plus 16, and the pulsar was 3 times as wide as it was supposed to be. And I confirmed with some people that was actually considered a large large pulse. I mean, it's a unique thing that happens with that pulse Pulsar. So we're going to get some science out of these things, and we'll write that one up for one of the journals here. But that's a very important thing, is to grab that raw data and plot it. Go ahead, Ray.
Yeah, well, I'll go ahead and talk about a couple other things that we're going to do with it in the last few minutes here. Last minute. The next thing is Skip and Steve Plock are going to be doing some SETI work, and they're also going to, with one of our other fellows, Tony, going to set the system up and with 1420 feed on the dish. And I took the 408s already down. The 1420 is going up very soon, and they will actually double check the actual alignment of our readouts to make sure and make any corrections that we need to make for the higher frequencies as the beam width goes down. And then right after that, in October and November, we're going to do some moon bounce on 1296 with the dish. So, and some tropospheric scatter work with maybe down as far as Texas and around. So we're going to put my 1296 system on it, and we will be on the moon during the ARRL moon bounce contest weekends for up to 1296, and that will be on October 10th and 11th, I believe, and then the latter part of November, around Thanksgiving time. And then after that was over, then we will put my 1420 feed on there and see how it compares to Steve's, and whether I got my system working well enough to do some. And then we'll start working on pulsars on 1420 for a while until the earlier part of the year. So we probably for the next 6 months at least have the system tied up with different studies. I think that ends it, Rich.
Yeah, and I want to tout Ray's ability. Ray made a pulsar simulator that produces pulses at different pulsar pulse rates and different pulse widths. And I've been using that. I actually have that tied into the receiver and to the computer here, and I'm able to generate pulsars that Presto picks up as pulsars. And I can change the, we got a frequency counter in there, and I can actually produce pulsars with this little box. And he's actually gonna, you know, right now he's got it sort of crystal controlled, but he's gonna put GPS timing in there, and we're gonna have very precise stuff. So that has been such a learning opportunity we test all the different modes on the Presto software and the GNU software and et cetera. With this this tool, and we'll put something together on that, because I think it has tremendously helped us learn the system. It's a great training tool. Okay. Okay, that's all we got. Any more questions?